Hey everybody, so in today's lessons what we'll be concentrating on is graphing linear equations. A linear relationship between two variables such as x and y whose graph is a straight line is called a linear relationship. So it basically refers to straight lines. The expression of that relationship as an algebraic formula such as y is equal to x plus 2 is called a linear equation. So basically anything that has an equal sign with variables involved, that's an equation. Yeah. So for question 1, graph each linear equation on a number line and write its x-intercept as well as its y-intercept. So normally what we did last year was we formulated our tables like that, and what we do is we substitute in each of these x values into that x value there. So for the first one, when we substitute in x is 0 into that spot, you'll have y equals 2 times 0 plus 1, which is y equals 0 plus 1, and that is equal to 1. So I'll write 1 in there, like that. For the next x-coordinate, you'll have y equals 2 times 1 plus 1, which is simply 3. So we'll write 3 there. And for the last one, y equals to 2 times 2 plus 1, which is simply 5. So I'll write 5 in there. So plotting these on my axes, using these pair of values as my coordinates, I'll have 0, 1, which is right there, 1, 3, which is 1 to the right, 3 up, like that, right there, and then 2, 5, which means 2 to the right, and 5 up, right there. Okay, then I just draw a straight line going through, okay, just like that, and just make sure that I have arrows at the very ends of my lines, and then what I have to do is find my x-intercept and y-intercept. So my x-intercept here is basically where it would intersect the x-axis. So if you have a look at the x-axis here, this is where it cuts the x-axis, which is -½ okay? And then for the y-intercept, okay, where it cuts the y-axis here, okay, that's where y equals to 1, okay? So our x-intercept, let's write that down, okay, x-intercept equals to -½ so that's where it cuts this line, right there. And the y-intercept is equal to the number 1. So that's where it cuts this line, which is right here. Right? Let's move on. Question B. Y equals to 2 minus 4x. So let's just substitute in x is 0. So 2 minus 4 times 0. Which is 2. Then 2 minus 4 times 1, which is the same thing as 2 minus 4, and that means -2. Last of all, y equals 2 minus 4 times 2, which is the same thing as 2 minus 8, and that's equal to -6. Okay, so let's plot these values onto the Cartesian plane. Here's my x and y axes. 0, 2 would mean 0 left or right, but 2 up. That's right here. 1, -2 means 1 to the right, 2 down, which is right here. There. And then 2 and -6 means 2 to the right and 6 down. So that would be somewhere around here. Okay. So when you join all these points up, it should make a straight line. Right there. Okay, let me just make that longer. Okay, there we go. So put arrows at the very ends of your line that you've graphed out. And then let's find out our x-intercept and y-intercept. So our x-intercept here. Okay. Our x-intercept is right between 0 and 1, which is right there. That's basically half. Whereas our y-intercept is simply this number here, okay, where it cuts the y-axis, which is number 2. Okay? Alright, moving on. Question C. Y equals to x plus 2 over 2. Now, when I look at these sort of equations, you can actually split them up into x over 2 plus 2 over 2. So each numerator is divided by that denominator. And you can simplify that down if you really wanted to. Okay, so you can read it both ways, like this or like this. And the reason why I kind of do this is because, see in the previous questions, I've always picked out 0, 1, 2. 0, 1, 2. Well, over here, I'm not going to pick that. I'm going to pick negative 2, 0, and 2 instead, because I like to actually pick numbers which are multiples of that denominator, which is number 2. Okay, or that denominator, which is number 2. So, if I was to just use this one here, okay, and I substitute in x as negative 2, that would be negative 2 over 2 plus 1, which is negative 1 plus 1, which is 0. That's 0. And then for the next one, if I substitute in 0, 0 over 2 plus 1 is 1. And then the last one, 2 over 2 plus 1 is 1 plus 1, which is 2. So there we go. We've got our coordinates ready. We can plot them into a Cartesian plane. So minus 2, 0 will be right here. 0, 1 will be right here. And 2, 2 will be here. Okay? So if I join that up to make a straight line, I get this line. And my x-intercept will be where it cuts the x-axis. So where it cuts this line here is negative 2. So we can say x-intercept equals negative 2. Whereas our y-intercept here is simply the number 1. Oops, sorry, it's positive 1. There we go. Okay. So now that we've known all about our x and y intercepts, which is basically where it cuts the x and y intercept, there is an actual different way to graph those lines by finding those and just simply joining 2 points instead of 3 or 4 that we've done. So there's a certain rule to this. All right. So to find the x-intercept, you substitute y equals 0. To find the y-intercept, you substitute x equals 0. And the reason why this is because if we have a look at this last example, I mean, this is an x-intercept. This is an x-intercept here, which is negative 2, 0. Whereas the y-intercept is 0, 1. So you can see that if you wanted to find out the x-intercept, okay, right here, whereas this is the y-intercept, okay, to find the y-intercept, you make this number equal to 0, which is the x value. Whereas if you want to find the x-intercept, you let this value here of the coordinate, which is the y value, to become 0. Okay? So basically, in summary, whenever you want to find an x-intercept, make the opposite letter, y equals 0. If you want to find the y-intercept, the opposite letter, x equal to 0. Alright? So it's very important that you write this rule down. Alright? And we'll start off by doing question A using that strategy. So, if I want to find out our x-intercept, okay, I will let y equal 0. So if I let y equal 0, then 0 equals 2x plus 4. And now I can solve this equation by subtracting 4 to the other side. So that minus 4 equals 2x, and dividing 2 over will get me negative 2. Whereas if I wanted to find out my y-intercept, I will make x equal to 0. So y equals 2 times 0 plus 4. Y would equal to 4, basically. Okay? So normally I write this up the very top each time I do this, and that would just guide myself and the teacher, whoever's marking it, on what I'm actually finding first, okay? And this little sign here, this means implies. Okay, it means implies. Right, so y-intercept implies x equals 0. Right, so now that I've done that, I can graph it out. Here we go. So on my x-axis, right here, right, I'm going to plot out x equals to negative 2. So if I go 2 to the left, and just plot out negative 2 there, there's my point. Then the next value is y equals 4. So I got to go 4 up the y-axis right there, and there's another point. So simply by just drawing a line through those 2 points gets me the line that I need to graph out. Okay, there we go. So I've successfully graphed this linear equation just by finding the x and y intercepts. Let's do the same thing with the next one. So if I find out my x-intercept of 6 minus x over 3, I'll have to make y equals 0. So 0 equals 6 minus x over 3. So I'll times 3 to both sides to get rid of that denominator. There we go. And so 0 equals 6 minus x, which means that x equals 6. Then if I was to find out my y-intercept, just by making x equals 0, then y would equal to 6 minus 0 over 3. So y would equal to 6 over 3, which is 2. Okay, so again, let's graph out this linear equation. So I need an x value as far as 6 to the right and 2 up. So 6 to the right will be here if I go up by 3's. 2 up will be somewhere there. So there's my y-axis, my x-axis, and I just make a straight line going through those 2 points, put arrows at the very ends, and I've successfully drawn my linear equation. Okay, question C. Let's find the x-intercept. Question C says x plus y equals 5, so if you were to find out the x-intercept by making y equals 0, you straight away get the x value, because once you make y equals 0, x plus 0 is just x, so therefore x would equal to 5. Whereas if I was to find out the y-intercept, okay, this means x equals 0, so if I make x equals 0, like that, then y equals to number 5. So when I graph this out, I'll have an x value of 5 and a y value of 5. Whoops, something here. Here we go. So here's number 5, here's number 5, and I'll just graph that out by connecting those 2 points. Here we go. Okay, so put straight lines at the very ends of those, and that's it. We've got it. In question D, we've got x over 3 plus y over 2 equals 2. Although it looks a bit complicated with all these fractions, it's actually quite easy to find out our x-intercept and y-intercept. So once we make y equals 0, you will start to notice that the fraction here, this one here, is going to disappear because it's just equal to 0. So then we get x over 3 equals to 2, which we then multiply 3 over just by doing that to both sides. And so x would equal to 6. For our y-intercept, if you make x equal to 0, 0 over 3 plus y over 2 would equal to 2. So 0 over 3 disappears since it's just 0. So you get y over 2 equals 2. We can multiply both sides by that denominator of 2 to remove it. Then y equals to number 4. So graphing this out. Oops, didn't make me a straight line. There we go. So we need to go as far as 6 on the right side, and also a y value of 4. So let me just put this down so that I make space for it. Here we go. That should be okay now. So x and y will be here. So if I go 6 to the right, that's 3, that's 6. And if I go as high as 4 upwards, that will be right there, 4 units up. And I just make a straight line like that. Okay, let me just make this a little bit longer. Here we go. Draw arrows at the end, and I'm done. Okay, moving on. Right, let's test if a point lies on a line. So if you have any kind of equation such as this, you are able to test any point. Let's just say if I test this point will lie on the line. But if I test this point here, which is the origin, that won't lie on the line. Okay? So we can do that algebraically. And it's by doing this. So a point lies on a line if its coordinates, x and y, satisfy the equation of the line. So for question 3, test whether each point lies on the line y equals 2x plus 3. So what we do is we split this equation into the left-hand side and the right-hand side. So the left-hand side of the equation contains the letter y. We're going to write for question A, LHS for left-hand side equals to y. And then we analyze the coordinate we're going to test. So 3 and 9, those are my x and y values there. Now, the number 9 is our y value. So we're just going to substitute that directly in. So that will be 9. Whereas the right-hand side says 2x plus 3. So we're going to substitute in x as 3 in. So we'll have 2 times 3 plus 3, which is going to be 9. So what do we actually see? The left-hand side of the value is equal to the right-hand side value. So that means that the coordinate will satisfy the equation, so it lands on the equation. So we say left-hand side equals right-hand side. So we can say 3, 9, that point lies on the line. Okay, let's test coordinate B, which is 8, negative 4. So again, the left-hand side of the equation says y. So we'll say left-hand side equals to negative 4, because in this case, the y value is negative 4, whereas the x value is 8. So the right-hand side of this says 2x plus 3. So we're going to substitute in x value as 8. So that will be 2 times 8 plus 3 equals to 16 plus 3, which is 19. So we can see now that these two values are not the same. So we can say, therefore, left-hand side is not equal to, so it's just an equal sign with a stroke passing through it, not equal to the right-hand side. So we can say, therefore, the point 8, negative 4 does not lie on the line. Okay, and that's how you test whether a point lies on the line. All right. Let's go into horizontal and vertical lines. A horizontal line is flat and runs across sideways, parallel to the x-axis. Every point on the horizontal line above, y coordinate negative 2, and the y-intercept is negative 2. So its equation is y is equal to negative 2. So if we just have a look at this graph here, this horizontal line, y is at negative 2. Well, if we analyze each point that I'm actually drawing purple, I hope you can see that, that point's going to be negative 4, negative 2. This point here is going to be negative 3, negative 2. And let me just do one more. This is going to be negative 2, negative 2. So what do you actually notice that are the same? It's these negative 2's, which are the y value. So it's consistently negative 2. Okay, it's always 2 units away from the x-axis downwards. So that's why it's called y equals negative 2, because all of them contain y values of negative 2. Okay? Whereas, if I was to have every point on the vertical line above has x coordinate 1 and the y-intercept is 1, then the equation is equal to 1. Okay. So, I forgot to mention that this line actually passes through the y-axis at negative 2. That's why it's y equals negative 2. But this line here passes through the x-axis. And the number it passes through is x equals 1. So we call it x equals 1. And the other reason also is because if we analyze each coordinate, if I just write a few of them, this is 1, 4, 1, 3, 1, 2, and so forth. So all the x values here are all 1s. So that means it has to be x equals 1 as our equation of this vertical line. All right. So, in summary, the equation of a horizontal line, if you think about it, it passes through the y-axis, so it has to be y equals some number. The equation of a vertical line passes through the x-axis, so it's in the form of x equals some number. All right. So, graph each line on the same number plane. So in this particular example, if you're writing this down, I think this is actually meant to be question 4. Just write question 4 instead. So, for question 4, A, if I was to graph x equals to 4, you'll look for the x value, which is on the horizontal axis, right there, number 4. And we're going to draw a vertical line going upwards, like that. And that is a line x equals 4. Okay, so pass through the x value of 4. For question B, y equals -2. So if I use a different color, -2 is down here as my y value. So if I have a horizontal line passing through that, like that, okay, that's y equals -2. Now, if I was to graph out x equals -half, look for -half on the x-axis on this line here. That'll be right there. So if I draw a vertical line like that, it passes through x equals -half. Okay, last but not least, we have y equals to 3.5. So 3.5 will be right here. Okay, just a bit above 3. So if I just make that horizontal line go across, there we go. We've got y equals to 3.5. Okay? So normally if we are to sketch all of these, it's actually quite good to write down what equations they are. So this one was y equals -2. The red one here was x equals to -half. The black line here is y equals to 3.5. And our purple line here was x equals 4. Okay?